Have you ever looked at old family photos and thought, wow, things were so different back then? It's a feeling we all get, a sense of nostalgia for a past we might not have even known. Well, what if I told you that our entire galaxy, the Milky Way, has its own good old days? A time when it was younger, wilder, and way more energetic than the calm, steady home we know today. Right now, if you look up at the night sky, everything seems pretty peaceful, right? A star is born here and there, but for the most part, it's a quiet cosmic neighborhood. On average, the Milky Way currently creates about 1 to 2 new stars per year, roughly the mass of our own sun. It sounds like a lot, but on a galactic scale, that's barely a whisper. Our galaxy has settled into a comfortable, predictable middle age, but it wasn't always this way. Let's rewind the cosmic clock, way, way back. About 10 billion years ago, our galaxy was a teenager, full of fire and fury. It was a turbulent, chaotic place, and it was churning out new stars at a breathtaking rate. Imagine a cosmic factory running at full blast, 10 times more productive than it is today. That means for every single star born in the Milky Way this year, 10 would have burst into existence back then. Can you even picture it? A sky blazing with the light of newborn stars, giant nebulae collapsing under their own gravity, and a galaxy glowing with the vibrant pink and blue hues of stellar nurseries. So, what happened? Why did our galaxy slow down so much? Well, like any great burst of activity, it couldn't last forever. The key ingredient for making stars is gas, vast, cool clouds of hydrogen and helium. In its youth, the Milky Way was flush with this raw material. It was constantly pulling in fresh gas from its surroundings, like a cosmic whirlpool gobbling up everything nearby. This abundant fuel supply powered the furious star formation we're talking about. Think of it like a bonfire. When you have a massive pile of dry wood, the fire rages, burning hot and bright. But as the wood gets used up, the fire gradually dies down to a gentle, glowing ember. That's essentially what happened to our galaxy. Over billions of years, that readily available gas was either converted into stars or blown away by the explosive deaths of massive stars known as supernovae. The galaxy's fuel tank started to run low. This period of intense star birth is what astronomers call a starburst phase. It was a critical time in our galaxy's life. It's when most of the stars that we see today were actually formed. The very structure of our galaxy, the beautiful spiral arms and the dense central bar, were shaped during this dynamic era. The stars forged in that ancient fire are still with us, including many in our own stellar neighborhood. One of the coolest things is that we can actually see this history written in the stars themselves. Astronomers can study the chemical composition of stars to figure out how old they are. The oldest stars in the Milky Way have very few heavy elements because they were born from the pristine gas that filled the early universe. Younger stars, like our sun, are richer in these elements because they were formed from gas that had been enriched by previous generations of stars that lived, died, and scattered their guts across the galaxy. By creating a census of stars of different ages, we can piece together the Milky Way's birth rate over cosmic time, confirming this dramatic slowdown. This story isn't unique to the Milky Way either. When we look deep into the universe with powerful telescopes like the James Webb Space Telescope, we're essentially looking back in time. And what we see are young, distant galaxies going through their own spectacular starburst phases. We see them in their chaotic, brilliant youth, just like our own galaxy once was. It's like finding the universe's baby pictures. It tells us that this live fast, die young approach to star formation is a normal part of galactic evolution. So, where does that leave us now? Is the Milky Way just fading away? Not exactly. It's more like it's enjoying a graceful retirement. It's still creating stars, just at a much more leisurely pace, and this quiet phase is actually incredibly important. A calmer galaxy is a more stable galaxy. The frantic, violent environment of a starburst galaxy, with constant supernova explosions and intense radiation, might not be the best place for life to get a foothold. Our galaxy's calm middle age may have provided the long, stable window necessary for planets like Earth to form and for complex life to evolve without being constantly zapped or disrupted. And the story isn't over yet. Our galaxy still has some gas left in the tank, enough to keep making stars for billions of years to come. Plus, In about 4.5 billion years, we're due for a major event, a collision with our nearest large neighbor, the Andromeda Galaxy. This cosmic merger will be a spectacular show. The gravitational forces will slam together the remaining gas clouds in both galaxies, triggering a brand new galaxy-wide starburst. The night sky of the future will be lit up once again in a final, brilliant blaze of glory as our merged galaxy, Milky Way, experiences a renaissance of star birth. So, the next time you gaze up at the Milky Way stretching across the sky, remember you're not just looking at a static collection of stars. You're looking at a living, breathing entity with a wild past and an exciting future. You're seeing the embers of an ancient fire that once burned 10 times brighter. A fire that forged the very elements that make up our planet, our bodies, and everything we know. Our galaxy may be old, but its story is one of the most epic tales in the entire universe. Thanks so much for joining me on this cosmic journey through time. If you found this as fascinating as I do, don't forget to hit that like button and subscribe for more adventures into the great unknown. Let me know in the comments what you think about our galaxy's fiery past. Until next time, keep looking up.